Okay, for page 5 we do have a little bit of new information, so please follow along. It says to copy each distribution, describe the distribution, and indicate if the mean or average is greater than, less than, or about equal to the median, or the middle data point. Well, let's take a look at the first set of data. In this blank space here, I want you to create a straight line as best as you can create it, and then make a mound like this. Go ahead and do this. Pause the video if you need to take some time to make your mound-shaped curve. Okay, what kind of shape does this look like? Well, one kind of shape this looks like, it is definitely mound-shaped. We've seen that before. It is also symmetric as well. And another way to describe it is normal. It is a normal curve. Mound shape, symmetric, normal. Now, what will happen with the average and the median? Well, the median is going to be in the middle of this set of data. Now, since we don't have any data, I'm going to give you just some hypothetical data. What if we had a 50, 60, 70, an 80, and a 90? Now, if we had more 70s in the middle propping this up, and we had an even amount of 60s on either side compared to the 80s, and the 90s and 50s were evenly balanced, this is what the shape or distribution would look like. The median would be right in the middle. So this is the median. But what do you think about the average? Well, put your finger to where you think it's going to balance. And in this case, the balancing point, if you had a large stack of 70s, medium stacks of 60s and 80s, and small stacks of 50s and 90s, let's say these were test scores, the mean will be the same as the median. So basically, about the same. So if you have a normal distribution, the median and the average will be about the same. Now let's look at a different shape or distribution. Can you think of another shape or distribution that's different than a mound, symmetric, or normal curve? Well, that's right. It would be skewed to one direction. Now, which direction? Well, let's take skewed to the left. Let's do that one first. Now, if this is skewed to the left, which way would the little slider go? Would it go this way from high to low, or this way from high to low? It would go this way from high to low. That's what skewed to the left looks like. Now, when you have something that's skewed to the left, what's going to happen is that your balancing point is going to get pulled to the left here. Now, if you put your finger too far out here, this is going to tip in this direction. So what you have to do is you have to nudge your finger out here so your balancing point ends up being left of center. So this right here is going to be your mean or average, denoted by the symbol x the bar over top of it. So where's the middle going to be? Where is the middle going to be? Well, the middle is actually going to be to the right of it. This is the median. So when you have a graph that's skewed to the left, the average gets dragged towards those lower numbers. That's why one or two low test scores can drag the average lower than the middle score. So the mean, if you have skewed to the left, will be less than the median. Now, if you want to see that out on paper, let's take a look at 5 numbers that's skewed to the left. Let's say we have a test score of 40, a test score of 70, a test score of 80, another test score of 80, and a test score of 100. So we have 4 test scores: 40, 70, 80, 80, and 100. Now if I add those up on the calculator that I need new batteries in, 40 plus 70 plus 80 plus 80 plus 100. Now to find my average, I take these numbers, I hit enter, get a total, divide by 5, and my average is 74. We'll compare the average to the median, which is 80. Is the average lower than the median? Because in this list of 5 numbers, 80 is the middle score. So yes, we haven't proven it, but we've shown you an example that shows that the average is less than the median. And there it is. Average is less than the median. So here's the median, 80. The average is 74. So it fits this example. And now we're going to try skewed to the right. And now what I want you to do is I want you to draw a picture of skewed to the right, and I also want you to answer this question. Where will the mean be? Will it be about the same, greater than the median, or less than the median? You can pause the video and give them a chance to do this. Resume when you're ready. All right, here we go. There's skewed to the right. The mean will be greater than the median, which means that that balancing point with your finger is going to get pulled to the right. So here's your X bar, or your mean, and over here is your median. Now let's look at a set of data that is skewed to the right. Let's say we have some low scores. We have a 10, we have a 10, we have a 20, we have a 30, and we have a 90. So there's a lot of low scores and one score that gets this tail dragged to the 90. Well, let's add these numbers up and see what they say. 10 plus 10 plus 20, and 20 is my median, plus 30 plus 90. That adds up to 160. If I divide that by 5, that's the total number. I bet that's going to be higher than 20, and it is, 32. So the average is higher than the middle score. All right, and that is the end of page number 5.